Hi, this is Paul from Foresight Tech. In this video, we are going to deal with the indeterminate difference using L'Hopital's rule. Let's see the outline. First, I will introduce a strategy which we can use to evaluate the indeterminate difference through L'Hopital's rule. Then we will practice two questions together about how to use the strategy. Let's see the material. Here is the indeterminate difference. Suppose we have two functions. Both limit of the function are infinity. Okay, so the question is how to find the limit of the difference of the two functions. Can you see? Which is infinity minus infinity, right? So it's indeterminable. Could it be any value? So we need a strategy. Okay, so here is the strategy. First, let me highlight. Okay, so it's here. Okay, so this is the strategy we can use to find the final answer. What does this mean? Okay, suppose now we have an infinity minus infinity. Okay, so what is the reciprocal of infinity? It's 0, right? Therefore, infinity we can write into 1 over 0. Okay, just put the infinity to the denominator. Okay, the same for the second infinity. Now, what do we have? We have two fractions subtract each other. Now, what does this mean? We can combine these two fractions together, right? So everyone knows after we combine these two fractions, what do we get? Definitely, we will get this indeterminate quotient, right? 0 over 0, which means what? And we can directly use L'Hopital's rule right now. Okay, so this is the strategy. Now let's practice this strategy together. Here is the first question. We have a limit of a difference, right? Let's check if the difference is indeterminate form or not. So the first cosecant, which is the reciprocal sign, and the 1 over 0, which is what? Is infinity, right? So the first is infinity. And the second is cotangent, goes down. At 0 is also goes to infinity, right? Can we see? Okay, so this is the indeterminate difference, right? And we follow the strategy. Okay, we try to make a fraction, right? So equal this. So let's make a fraction. Very easy to make this time. The first cosecant is the reciprocal of sine, right? So that's 1 over sine x minus. The second cotangent is the quotient rule, right? Of cosine over sine x. Can you see? Now it's good. We have a two fraction. Okay, let's going to check if the two fraction is 1 over 0 or not. So the first is 1 over sine 0 is 0. Good. Minus. The second is cosine 0 is 1 over 0 again. Can we see? And then we definitely have this kind of a fraction. What do we do now? Combine the two fractions, right? Okay. So we're going to combine the fraction. And then the denominator, of course, is the same, sin x. The numerator is 1 minus cosine x, right? Okay, so it's a cosine x. Now we have a single fraction. We're going to check, okay, the type. The numerator is 1 minus cosine at 0. 1 minus 1, what? 0. Over denominator sine 0 is 0. What do we do now? L'Hopital's rule, right? Okay, it's good. So now we have L'Hopital's rule directly. Okay, and then which means we need to take a derivative. Okay, so we're going to take a derivative to the top, which is a cosine take a derivative negative sign. Negative goes to positive, so it's a sign. The denominator, I take a derivative, is a cosine. Now, what do we get? Okay, what directly substitute? Sine at 0 is 0. Cosine at 0 is 1. See, the answer now we know is 0, right? Good. And now let's practice one more question. Here is the last question. And we have a limit, okay, so of the difference, right? The same, we're going to check. And the first term is 1 over 0, which means what? Infinity, right? So the first is infinity minus the second 1 over e raised to the 0's power, which is 1. 1 minus 1 is 0. Therefore, this is the infinity. See, so this is the type, right? So we need to deal with. So now what do? We follow the strategy. We need to make a fraction. Do we really need to do something? No, this, can we see, is already, we already have a fraction. And you can see what the first is still 1 over 0 minus the second is also 1 over 0, which means it's already fraction down here. Okay, we do not need to do anything. All we need to do now is just combine the fraction directly. Okay, let's combine the fraction. I put them together now. What do we have? We have this big fraction. Okay, the denominator should be x times ex minus 1, right? The numerator is goes to ex minus 1 minus x. Can we see? Now we have a single fraction. We're going to check the numerator, which is 1 minus 1 minus 0, which is what? 0. Good. The numerator is 0. The denominator, of course, x times anything is 0, right? It's already 0. See? What do we do now? Log b does rule, right? Of course. We're going to use log b does rule. So take a derivative, right? We're going to take a derivative. Okay. And see, I take a derivative to the numerator. Now the first is ex, right? The second is 0. So the third is minus 1. I take a derivative to the denominator, which is a product, right? I have to use a product rule. Okay, take a derivative to x, which is 1. So we have this ex minus 1, right? Plus, and then take a derivative to the second term, which is ex. So we have a plus x times ex. And the denominator, we use a product rule, okay? Now, have we got the answer? I don't know. I have to check, right? So let's check. The numerator is 1 minus 1, which is 0, right? The denominator is 1 minus 1 plus 0, which is still 0. What do we do? Okay, see, we have to use log beta's rule the second time, right? We already used the first time. Now we use the second time. Don't worry, just going to take derivative, okay, again. So I will take derivative again. See, the numerator, so is ex minus 0, right? The denominator this time are going to ex minus 0. I ignore the 0. And then plus, there's a product again. I'm going to use a product rule. Okay, so plus x take derivative is 1, so is ex, right? Plus x times the derivative of ex, which is the self, so x times ex. See, what do we get? This time looks complicated, but we can simplify, okay? You know how to simplify. It's easy to simplify because what? Because we have a common product which is e raised to the x power, right? If we have a common factor, okay, so we divided out e raised to the x power, both the numerator and the denominator. See, what do we get? 1 left. The denominator is 2 plus x. See, this is simple, right? Directly put the 0 in is 1 over 2. This is the answer already. Okay, that's all. Thank you. I hope you enjoy learning on this topic. If you have any question, please leave your comment. If you like this video, please give me a thumbs up. Thank you for your support. Please don't forget, you are very welcome to subscribe to my channel for more videos. In the next video, let's see. We are going to deal with the indeterminate power using L'Hopital's rule. Hope to see you there. Thank you. Have a nice day. Bye.